Welcome to episode 5 of our series. I'm Maria and joining me again is Hristo, our host. So far we have covered microservices, containers, DevOps, cloud fundamentals and the basics of Kubernetes. Today we're asking the big question. Should you run Kubernetes yourself or let Azure handle it for you?
Hey everyone, now that we've covered what Kubernetes is, it's time to talk about how to actually run it in the real world.
Okay, let's start with something simple. What is the real difference between self-managed and managed Kubernetes?
Good question, Maria. So in self-managed setup, you do everything yourself. So you provision virtual machines, you install the control plane, configure networking, handle security, patches, and upgrades. And with Azure Kubernetes Services, or AKS in short, Microsoft takes care of the control plane, the API server, scheduling, and upgrades. You just manage the worker nodes and applications.
So managed doesn't necessarily mean hands-off.
Indeed, so Microsoft manages the control plane, but you still own the data plane, your workloads, nodes, and configurations.
What are the trade-offs?
Self-managed gives you the maximum control, custom setups on premises or hybrid, no vendor walk-in, but demands time, skill, and constant maintenance, of course. So managed services like AKS trade some control for simplicity. You get the automatic upgrades, built-in high availability, and deep integration with Azure identity, networking, and monitoring, for example, and other tools from their ecosystem. And financially, AKS is efficient because you pay only for the worker nodes. The control plane is free in standard.
How should organizations decide which one to use?
We should ask ourselves, is Kubernetes part of our core business? If we have a platform engineering team with strict compliance or custom hardware, for example, um, self-managed might fit, but for most, really 80 to 90% in use cases, AKS is the right balance.
Azure has a bunch of container options. Where exactly does AKS sit into this landscape?
So, Maria, think of it as a spectrum of control. Azure Container Instance, for example, is the oldest and simplest management for containers from Microsoft. It's managed Docker based, but it's legacy with limitations. I recommended to use the second option, which is the Azure Container Apps. It's newer and built and deploys serverless microservices. It's easier and simple, and containerized application on serverless platform. So the third one is the AKS, as we talked. It's a full Kubernetes experience with managed control plane. You get native Kubernetes APIs, operators, Helm, and more. For specific workloads, you also have options like Azure Red Hat OpenShift, Azure Service Fabric, Web App for containers, and Azure Batch.
So the difference isn't just convenience, it's integration also.
Exactly. So the AKS ties directly into Azure's ecosystem. Think of it for example, for networking, we have full VNet integration, Azure CNI for routable pod IPs, VPN, and network policies that are enforced natively. For storage, we have persistent volumes backed by Azure disks or Azure files. For identity and security, we have Entra ID, or formerly Azure AD. We have Key Vaults for secrets and Defender for containers. For monitoring, we have Container Insights and Log Analytics that are built in. And for Container Registry, there is a tight integration with Azure Container Registry for image builds, signs, and secure pools. And in automation and CI/CD, AKS connects easily with GitHub Actions and Azure DevOps pipelines for continuous deployment. Policy and compliance part, the Azure policy for Kubernetes lets you enforce standards, approved images only, for example, required labels, no privileged containers allowed as well.
So basically, AKS isn't just managed Kubernetes. It's Kubernetes that is wired into Azure from networking to security and to even monitoring.
Exactly, Maria. And that integration layer is what turns Kubernetes from DIY infrastructure into a production-ready cloud service. With self-managed clusters, you'll be wiring all that together manually. Container registry, storage classes, Prometheus, Grafana, cert managers, DNS, and many, many more. Um, with AKS, you save weeks of setup.
Let's go under the hood. How does AKS actually work?
AKS has two main parts. First one is the control plane. Managed by Microsoft, it's free and highly available across zones. The second one is the node pools, your virtual machines where workloads run. So you can mix pools. For example, you can have Linux and Windows. You can use standard and GPU nodes, even burstable spot instances.
That's clear. So the control plane is Microsoft's responsibility and the node pools are yours. How does AKS handle scaling between those two layers?
So scaling in AKS happens at two levels. So first you have pod level scaling. The horizontal pod autoscaler adds or removes pods based on the metrics like CPU, memory, or custom metro caps. Second one is the cluster level autoscaling. If there aren't enough nodes to fit those pods, the cluster autoscaler automatically adds new virtual machines to the pool. When demand drops, it scales them down again.
So it is elastic by design. It grows and shrinks as we need it. But what about resiliency and security?
So for the availability, the control plane is automatically replicated across zones, and you can distribute your node pools across those same zones. That means even if an entire data center goes down, your workloads keep running. For security, AKS integrates tightly with Azure's native tools. For Entra ID, the authentication and single sign-on with Azure RBAC and Kubernetes RBAC, you have the mapped together for fine-grained access. Network policies and private clusters, so the API endpoint isn't public. We have Azure Key Vault for secret management. Defender for containers is for image and runtime scanning. And if you want extra protection, you can enable Azure Private Link, which encrypts the traffic from your own with your own managed keys, and even enforce policies at deployment time using Azure Policy for AKS.
Let's talk about operations. What's life like managing AKS day to day compared to a self managed setup?
Okay, so let's run through a few examples, Maria. For upgrades, as we said, on self-managed, you coordinate control plane and node updates manually. With AKS, control plane upgrades are automatic, and you can schedule maintenance windows for nodes. For scaling, on self-managed, you monitor and resize manually. In AKS, it handles with built-in autoscaler. For the security part on self-managed, you manage certs, RBAC, and secrets. And with AKS, it integrates with Entra ID. We have Key Vault, Defender, and Azure Policy from day one. For the monitoring part on self-managed, you deploy and maintain your monitoring stack entirely. And in AKS, it gives you the insights via the Azure Monitor out of the box. For the cost on self-managed, you pay in infrastructure and engineering time. And with AKS, the control plane is free in standard. And you can use spot instances or reserve nodes for optimization.
So, in short, self managed is about infrastructure first, and AKS is application first.
The AKS uniqueness is in that balance. So you still get full Kubernetes API access and flexibility, but Microsoft handles the heavy lifting, high availability, scaling, security patching, and integration with the Azure ecosystem.
So, to summarize, self-managed Kubernetes gives you ultimate control but demands expertise, time, and maintenance. Managed services like AKS offer simplicity, security, and scalability without headaches.
For most teams, AKA is practically the best choice for production-grade Kubernetes with Azure reliability backed in.
Thank you, Hristo, again. Next time we'll stay in the managed world and explore Red Hat OpenShift, another flavor of Kubernetes, but with a different approach.
Can't wait to see you next time in episode 6. Goodbye, everybody.